Okay, so we start with the first question. Find the derivative of f of x if f of x is x cubed plus 3x squared plus 2x plus 1 using the definition. So using the definition means you must use the first principle. You're looking for f prime of x. This is equal to the limit as h goes to 0 of f of x plus h minus f of x, everything is over h. So everywhere you have x, you're going to replace the x with x plus h and then simplify. So as long as you have not substituted, you need to keep writing this limit as h goes to 0. So here you'll have x plus h cubed plus 3x plus h plus 2x plus h plus 1 minus x cubed plus 3x squared plus 2x plus 1, and this is all over h. So this is the limit as h goes to 0. We have x cubed plus 3x squared h plus 3x h squared plus h to the power of 3. So you multiply this out where you put x plus h times x plus h times x plus h. This is what you'll get. Then this should be squared, I believe. Okay, then we have plus 3x squared plus 2xh plus h squared plus 2x plus h, and we have plus 1 minus x cubed minus 3x squared minus 2x minus 1, and this is all over h. So the plus 1 and the minus 1 already will cancel, and the x cubed minus x cubed will cancel. Then we continue. So I still haven't substituted, so the limit as h approaches 0 must still be there. So I have 3x squared h plus 3xh squared plus h cubed plus 3x squared plus 6xh plus 3h squared plus 2x. I shouldn't have written the 2x. So you can see here the plus 2x and the minus 2x will cancel. So I have just plus h. The 1 is canceled, this is canceled. Then I have minus xh, okay. Minus 3x squared over h. Okay, so plus 3x squared and negative 3x squared, those will cancel. Now, what is always going to happen with these polynomials is you'll get to a point where all the terms that do not have an h cancel. So if you get to this stage here and you still have terms that do not have an h and cannot cancel with anything, more than likely you did something wrong. So you need to check what you did. So now we'll factorize h. We have 3x squared plus 3xh plus h cubed plus 6x plus 3h, and then I have plus 1. This is all over h, and these two will cancel. So now I have the limit if h goes to 0 of 3x squared plus 3xh plus h cubed plus 6x plus 3h plus 1. And now when I substitute h is equal to 0, I no longer write the limit. So this is 3x squared plus 3x times 0 plus 0 to the power of 3 plus 6x plus 3 times 0 plus 1. This gives me 3x squared plus 6x plus 1. And if you've done it using the short method, the 3 will come down. We will have 3x squared. Then the 2 will come down, multiply with the 3, you get 6x, which is what we have, plus 2. Okay, what did I do wrong there? Okay, I see what I did. I missed here, dear. This is 2h. Okay, so the good thing is we know how to do it. Just erase that and I'll highlight my mistake in red. So here I had written h. So this should be a 2. So I can check my answer and see, okay, it's not correct. Then I go back through my working and see what I did wrong. So this should also be a 2. This should be a 2. This should be a 2. And then here we would get a 2, okay? So very easy, you go through the working, then if you made a mistake, you look at your final answer. If it doesn't satisfy what you have there, then you just go back and check where did you make the mistake and you can easily correct it. But for 6 marks, you must do it in this way. You cannot do it any other way. Okay, then the next question. Differentiate y is equal to theta 3 theta over 4 to the power of 0 plus 2t squared theta minus 2x with respect to theta. So since we're differentiating with respect to theta, it means t is a constant, x is a constant. So dy d theta. Okay, first of all, notice that this one is to the power of 0 and anything to the power of 0 is 1. So over here, we just have theta. The derivative of theta is 1. And then here we say 2t squared is a constant. So with a constant multiplying by theta, the derivative is that constant. And then here there's no theta. That means it's a constant. So the derivative is 0. Then 1.3, if y is equal to the square root of sec theta, show that dy d theta is equal to half tan theta square root of sec theta. Okay, so we can rewrite y. This is equal to sec of theta to the power of a half, and then we want to differentiate this. Okay, so sec theta, we can rewrite this as 1 over cos theta to the power of a half. And this we can write as cos theta to the power of negative half. And then we want to differentiate this using the chain rule. So dy d theta. On the outside, we have power negative a half, so negative a half should come down. Then cos theta to the power, it stays the same, of negative a half minus 1 is negative 3 over 2. And then we move to the inside. The derivative of the inside is negative sine theta. Okay, this negative and that negative will make positive. So I have a half sine theta times cos of theta to the power of negative 3 over 2. So remember what we want to prove. So now it becomes like an identity. We want to simplify this so that it is this. So we rewrite it. This is a half sine theta times 1 over cos theta to the power of 3 over 2. So we rewrite it with a positive exponent. And then we can write this as a half sine theta times 1 over cos theta times the square root of cos theta. So I'm just playing around with my laws of exponents. Then this is a half sine theta over cos theta times the square root of 1 over cos theta. And then this is a half. This is tan theta. And this is the square root of sec theta. Okay, and that is how you prove that that is the derivative. Next question. Find a point on the parabola y is equal to x minus 4 squared, where the tangent is parallel to the chord joining this line. Now, what we know about the derivative is that the derivative, this is the gradient of the tangent line. Okay, that is the definition of the tangent line at a point on the curve. Okay, so it is the gradient. So if we want to find the gradient, we want to find the tangent, all we need to know is the point where the tangent meets the curve and the gradient. So the gradient, we know it is going to be the same as the gradient joining these 2 points because the 2 lines are parallel. So I'm going to work out the gradient of the tangent. This is equal to delta y over delta x. So this will be my x1, y1, x2, y2. So I say 1 minus 0 over 5 minus 4. This is 1. Okay, so my gradient of the tangent is 1. And then because when I differentiate this, I also get the gradient to the tangent. So I can differentiate that, equate to 1, and then solve for x. That will give me the point where the tangent line touches the curve. So remember, again, you have a parabola like this. A tangent is a line that touches the graph only at 1 point. So it touches only at 1 point. So we know the gradient of this tangent line because it's parallel to these 2. And when we differentiate this one, it also gives us the same tangent. So they are obviously equal. So we find dy dx. This is, we differentiate this using the chain rule. The 2 comes down. We have x minus 4 to the power of 1. We don't need to write it. And then multiply by the derivative of the inside, which is 1. Okay, so we're saying these 2 are equal because they are both giving me the gradient of the tangent. So we say 2x minus 8, so I multiplied out, is equal to 1. So 2x is equal to 1 plus 8. So this means 2x is equal to 9. So x is equal to 9 over 2. So now I need the y coordinate. So the formula for y is this one here. So I have 9 over 2 minus 4 to the power of 2. So when you work it out, this is 4.5 minus 4. So this is a half squared, which is 1 over 4. So I have the gradient is 1, and the point is 9 over 2, comma 1 over 4. I can work out the equation of the tangent. So equation of the tangent. Use the formula y minus y1 is equal to mx minus x1. So the point of tangency, that means this point here where it touches the graph is 9 over 2, comma 1 over 4. All right, so we now substitute. We have y minus 1 over 4 is equal to, the gradient is 1, x minus 9 over 2. Okay, then we just write this in standard form. Y is equal to x minus 9 over 2 plus 1 over 4. Y is equal to X. We add these two together. We get minus 17 over 4. Okay, so this is the equation of the tangent to the parabola that is parallel to the line joining these 2 points. Okay, question 2.1 says find the domain of this function. So remember, in the domain, we need to make sure our denominator, x squared minus 9, is not equal to 0. And we need to make sure that what is under the square root is greater than or equal to 0. So we solve these two, and then that will tell us what our domain is. So here, x squared is not equal to 9. So this means x is not equal to 3. And x is not equal to negative 3. And here we have x is greater than or equal to 3. Okay, but then remember, x cannot be equal to 3. So our domain, these are all the x real values. X must be strictly greater than 3. So negative 3 is automatically out when you take this one, because both of these must be true. So negative 3 is definitely not included here, but 3 is included here, but it must not be included in the domain. So that is why we have a strictly greater than inequality there. 2.2, prove this identity for 6 marks. So like I said, you need to work on one side and one side only. The left-hand side looks more complicated, so that's why I'll pick that one. So we have 10x plus 10y over cot x plus cot y. Okay, so most of the time I say, if you're not sure what to do, write the trigonometric ratios in terms of sine and cos. So this you can write as cos y over sine y multiplied by sine x over cos x plus sine y over cos y. And this is over cos x over sine x plus cos y over sine y. Okay, then simplify or add these two fractions. We write it over here. So we still have the cos y over sine y. And then here we'll have sine x cos y plus sine y cos x over cos x cos y. That's the numerator, this one here, when I add them together. And then this is divided by sine y cos x plus sine x cos y. And this is divided by sine y sine x. Okay, so if we look at these two numerators here, sine x cos y, that's this one here, and then sine y cos x, that's this one there. So these two are the same. So when I change this division to multiplication and then have the reciprocal, they will be able to cancel. Okay, so we have sine x cos y plus sine y cos x over cos x cos y times sine y sine x over sine y cos x plus sine x cos y. Okay, so we say this numerator is exactly the same as this denominator, so they cancel. And then sine y here can cancel with that sine y there. cos y here can cancel with that cos y there. And then we're left with sine x over cos x, and this is just equal to tan x, and that is the right hand side. Okay, 2.3, AC represents a vertical tower which is perpendicular to the horizontal plane BCD at C. Okay, so you should see that AC is in the air, it's a building. Okay, and BCD is on the ground. Then we're told that AB is 2 units, BCD is 90 minus theta, so this angle here. Then BDC is 2 theta units, and then BAC, this angle here, is theta. So this is an angle that is in the air. All right. Then show that BD, this length over there, is 2 sine theta cos theta over sine 2 theta. Okay, so we're trying to work out BD. What we can do is we can work out this angle here. We can call it X. Okay, if we work out angle X, we'll have all the angles in the triangle. Then this one here, BC, we can work it out. So let me call it Y. If we work out Y, we have all the angles, and then we'll just use the sine rule to work out BD. So first we need to work out Y. So the triangle we have ABC looks like this. So we have A, C, and B is here. This is 90 degrees. This angle there is theta. So this is 2 units. So we have the angle theta here. We have the hypotenuse. We are looking for the opposite. So we can see that sine of theta, this is equal to the opposite, which is y, over the hypotenuse, so y over 2. And then we make y the subject of the formula. This is 2 sine theta. Okay, so now we move on to the second triangle, BCD. Now we have BCD, so this is 2 theta. This is 90 minus theta, and this is 2 sine theta. So we're looking for this one here. Let's call it Z. Okay, so we can use the sine rule. So we see that Z over sine of 90 minus theta. This is equal to the opposite, is equal to this one here, 2 sine theta over sine of 2 theta. Okay, now this is an identity, complementary angles, so we should know that this is Z over cos theta, and this is equal to 2 sine theta over sine 2 theta, and this means that Z is 2 sine theta cos theta over sine 2 theta. Okay, so this is what we have. And this is actually, in fact, equal to 1, even though that's not what we're trying to show. So we have BD is equal to 2 sine theta cos theta over sine of 2 theta. 2 theta. Okay, so the reason I say this is equal to 1 is because sine 2 theta, the identity is 2 sine theta cos theta. Okay, so in the 2021 paper, not all the questions are applicable to what will be in the test. So there's only these two questions. The other ones are on vectors and applications of differentiation, which will not be covered in the test. So I will not cover them in this video. So these two, we have to differentiate the function. We'll start with 2.1. We have y is equal to sine to the power 4 of x plus 2e squared x with respect to x. So remember, this means sine x to the power of 4. So using the chain rule, y prime, the 4 will come down at the top. We subtract 1, and then we multiply by the derivative of the inside, which is cos x. And then here, remember, if we're differentiating with respect to x, every other letter is a constant. So here I have a constant multiplying by x, so the derivative is just the constant. So this is your final answer. Plus 3e squared. Okay, then 2.2, differentiate y is equal to 1 over x using the first principle. So with this question, you cannot do it in the short way. You must differentiate it using the definition. So our definition, dy dx, this is the limit as h goes to 0 of f of x plus h minus f of x over h. This is the limit as h goes to 0 of 1 over x plus h minus 1 over x over h. And then we combine these two fractions. This is a limit as h goes to 0 of x minus x plus h over x times x plus h, and then it's divided by h, so this h will go to the denominator. So we'll have the limit as h goes to 0 of x minus h over x plus h times h. So these two will cancel. Then we have the limit as h goes to 0 of minus h over x plus h times h, which is the limit as h goes to 0. These two will cancel, of minus 1 over x times x plus h. And then we substitute h is equal to 0. Then when I substitute, I do not write the limit as h goes to 0 anymore. So this is plus 0. So this is minus 1 over x times x, which is minus 1 over x squared. And again, if you had just done it the short way, just to check that your answer is right, you'd write it as x to the power of minus 1. Then the derivative, the minus 1 will come down. At the top, you subtract 2, and this is negative 1 over x squared. So our working is, in fact, correct. Okay, on to 2022 paper. We have to prove that the derivative of f of x, which is x plus 1 over x, is 1 minus 1 over x squared using the first principle. So we have f prime of x. This is the limit as h goes to 0 of f of x plus h minus f of x over h. This is the limit as h goes to 0 of x plus h. So I replace x plus h here, plus 1 over x plus h minus x plus 1 over x. This is all over h. This is the limit as h goes to 0 of x plus h plus 1 over x plus h minus x minus 1 over x. So these two will cancel. And then these two here, just like the previous one I did, we will combine them. So I have the limit as h goes to 0 of h. Then these two, combining them, I have x minus x plus h over x times x plus h. This is all over h. So this is the limit as h goes to 0 of h. This one, we know we'll get minus 1 over x plus h, everything over h. Then we can split this up. This is the limit as h goes to 0 of h over h minus the limit as h goes to 0 of 1 over x plus h over h. So using our limit laws, the limit of a difference is the difference of the limits. Okay, so we have, sorry, over here, I have h not 1. Okay, so this 2 will cancel, the minus h should still be there. So this h there will cancel with that one. So minus the limit as h goes to 0 of 1 over x plus h times x. So this one we know is just 1 because 1 is a constant, it doesn't depend on h. And over here we substitute 0, so we have minus 1 over x plus 0 times x, we get 1 minus 1 over x squared. Okay. Okay, so we want to solve this equation. Cos squared x plus cos x is equal to sine squared x. So first thing, we need to rewrite everything in terms of cos x. So we have cos squared x plus cos x. This is equal to sine squared x. So sine squared x, we use our identities. This is 1 minus cos squared x. Then collect everything on one side. We have 2 cos squared x plus cos x, and then minus 1 is equal to 0. Now this is a quadratic equation which you can factorize. We look for two numbers. When we multiply them, the answer is negative 2. When we add them, the answer is positive 1. So that's positive 2 and negative 1. So we factorize this. Okay, so this is what you get when you have factorized it. If it's easier for you, make a substitution. So maybe write it as 2m squared plus m minus 1, where m is cos x, factorize it, and then rewrite it in terms of cos. So this means that cos x plus 1 is 0, or 2 cos x minus 1 is 0. Now we come to step number 1. So cos x is equal to negative 1. And here cos x is equal to a half. That is step number 1. You make cos the subject of the formula. Step number 2, you find your reference angle, alpha. This is cos inverse of 1. You ignore the negative, and we will get 0. Okay, then the next step is your quadrants. This is negative, so you are looking for the second and the third quadrant. So in the second quadrant, x is equal to 180 minus 0. So this is just 180 degrees. And then in the third quadrant, x is equal to 360. 180 plus 0, so this is still 180 degrees. So there's only one solution over here. All right, then the second equation, we do the same thing. Alpha, this is cos inverse of a half, which is equal to 60 degrees. Then your quadrants, this is the first and the fourth. In the first quadrant, x is equal to 60 degrees. In the fourth quadrant, x is 360 minus 60, which is 300 degrees. So our solution set We have x is equal to 60, 180, and 300 degrees. The fifth step, which is adding 360, you would try it, but they are out of the range. So something here, we're only looking for angles between 0 and 180. So actually, this one here is not a solution because it's not in the range that we're looking for. So we have only two solutions. So keep in mind the range that is given over there. 3.2, we have to prove this identity. Remember, you must pick one side and work only on that side. So sine x over 1 plus cos x. Okay, so where do we want to go? We want to get to sine x in the denominator. So what we can do is multiply this by 1 minus cos x over 1 minus cos x. So 1 minus cos x over 1 minus cos x is 1. So when we multiply this by 1, we haven't changed anything. So we'll have sine x 1 minus cos x over, this is the difference of squares. We have 1 minus cos squared x. Then 1 minus cos squared x we know is sine squared x. And these two will cancel. In the denominator, you're left with sine x. So this is 1 minus cos x over sine x, and this is the right-hand side. Okay, so 2.3, we're given a function f and g, and we have to find the domain of the composition of f and g. So that means g of x is going to be put into f of x. We come up with a new function, and then we work out the domain of that function. So first we need to work out f of g of x. This is f of the square root of x plus 3 over x minus 2. And this is 2. Wherever we have x, we put this instead and square it. We have the square root of x plus 3 over x minus 2 squared. And then we have 4. Okay, so we simplify. We have 2 x plus 3 over x minus 2 squared. And then we have 4 square root of x plus 3 over x minus 2. Okay. Then we can multiply out, but it's not really necessary to help us find the domain. So remember, with the domain, the only thing is the denominator must not be 0. So x minus 1, x minus 2, sorry, is not equal to 0. Also, x minus 2 squared is not 0. But if x minus 2 is not 0, then automatically x minus 2 squared is not 0. So this one is not really necessary to write. And then anything we have under the square root, x plus 3, must be greater than or equal to 0. So we need a combination of these two. So from the first one, x minus 2 is not 0. Repeating this, x is not equal to 2. And here, x is greater than or equal to negative 3. So our domain, write it like this, x is a real number. X is greater than or equal to negative 3. And the key word here is and, not or. And x is not equal to 2. Okay, so that is how you would write your domain. Okay, so those are all the questions in the test 3 papers that are applicable to what will be covered in this test. So questions on the tangent, the normal line, and all the other applications of derivatives will not be in the test. So there are some questions in past test 2 papers that are applicable to the test. There's a link that I've sent you guys to those memos so you can also go through. Okay, so good luck with the test.